Hi guys, so welcome to your last skill for polynomials. Alright, I want you to create a polynomial with specific zeros. So this is a little bit of a stretch from what we've done in class, but not anything you guys can't handle. So one thing that I'm going to change right away, it says write a polynomial function of least degree that has integer coefficients, the given zeros, and the specified end behavior. We're just going to add in here in standard form that has integer coefficient. I guess the standard form could go here. So we're going to add that here. So it says write a polynomial function of least degree that has integer coefficients in standard form, the given zeros, and the specified end behavior. Okay, so this is kind of taking a lot of different skills that you guys have and putting it into one just problem. So here I want you to have a single zero at -4, a double zero at 5/3, and I want your polynomial to have this end behavior. All right, so let's decipher this part one at a time. A single zero at x minus 4. So that means when I have the factor and I set it equal to 0, I should be getting x equals -4. In order for that to happen, I would have to subtract 4 from both sides. The reason I would subtract 4 is that was a positive 4, and I still need an x somewhere. So that means my factor for that is just an x plus 4. All right, so here, double zero at 5/3. So you guys did come up with that relationship last class of if I have a fraction a over b, the factor is bx minus a. So if we plug that in here, that looks like it would be 3x plus 5. And then again, you can double check by setting this equal to 0. I made a sign error, right? So it's good to double check. So if I added 5 to both sides, and then I would have 3x equals 5, divide by 3, it works. All right, so that's how you would write a single zero, but I want a double zero. And that means I would square this, right? So in order to have two zeros, I would have to have that zero twice. So if I have it twice, right, that's like 3x minus 5 times 3x minus 5. And so that's 3x minus 5 squared. All right, so that's how I have my double zero. Here, end behavior, I'm just going to give myself a sketch. So it says as x goes to -infinity, y goes to +infinity. So that would look something like that. And as x goes to +infinity, y is going to -infinity. So something like that. So you also have to know end behavior for this part. But you guys are doing really well. Remember, there's only 4 different types of polynomials. Here, this would basically determine that I need to have a negative leading coefficient. I need to have a negative leading coefficient because this polynomial's end behavior tells me that it's a negative coefficient. And if you're not sure about how to figure out end behavior, you can go ahead and click the link that I'm putting in right now, and that will take you to end behavior, and that should help you guys out. But we're going to go ahead and move on with this problem. So I want standard form, which means I need to take all this information. All right, what I'm going to do is I'm going to go ahead and multiply this out. I'm going to actually use box method because I think it's a little cleaner. So I'm going to multiply 3x minus 5 times 3x minus 5. That would give me 9x squared minus 15x minus 15x plus 25. All right. So that gets me 9x squared minus 30x plus 25. So that's this part, right? That's that. But I didn't take into account my x plus 4. So what I'm going to do, that's fine. What I'm going to do is I'm going to multiply one more time. All right, and this is where box method really is kind of more helpful. I'm going to do x and the plus 4 here. And then I'm going to do 9x squared. Oh, my x disappeared. Stop. Oh, one note. Minus 30x. Oh my god. Hang on. Okay, let's try that again. So 9x squared minus 30x plus 25. Again, I'm just gonna, oh, that was supposed to be an x plus 4. All right, so I set up another box. I'm gonna go ahead and multiply. That's 9x to the third minus 30x squared plus 25x. That's 36x squared. That is 369 minus 120x, and then that's 100. So the cool thing about box method is my like terms are on the diagonals. So that means this result is getting me, I'm actually going to write it down here, 9x to the third That's a plus 6x squared. That's a minus 95x plus 100. All right, but if you look, right, this method right now, I have a positive leading coefficient of 9. I need a negative leading coefficient. So what I'm going to do in order to fix that is multiply this polynomial by -1. So my final result, which I'm going to go ahead and write in green, is negative 9x to the third minus 6x squared plus 95x minus 100. All right, and that equals y. Sure. I'm not going to take off if you guys don't put equals y. But yeah, that is a polynomial function that has this single zero, that double zero, and this end behavior, right? Because it's a degree 3, it's odd, right? These shouldn't match. That works. So there you have it. I created that polynomial with zeros and that end behavior. All right. Thanks, guys. Good luck.